All right, this is the key to test one. So in problem one, it says solve the following rational equation, and then it says show all work. You need to clear the fractions at the beginning of the problem. So that's the way I wanted you to do it. So that's why it said, so the big hint was that you had to clear the fractions at the beginning of the problem. Don't use any other method. Okay, so the first thing you have to do also is state the least common denominator and also state the restrictions. So before you can find the least common denominator, you need to make sure that all denominators are factored completely. So x minus 4, I cannot do anything with. I cannot factor that any further. X plus 2, I cannot factor that any further. But x squared minus 2x minus 8, I can factor as x minus 4 times x plus 2. And so that's so once you factor all the denominators, then your least common denominator will include every factor that you see in the denominator. So x minus 4 occurs as a factor. I'm going to use it as part of my least common denominator. Because remember, the whole point is to clear the fraction. So if I want to make this a factor of 1, if I want to clear that fraction, then I've got to multiply by x minus 4. So that has to be part of your least common denominator. Same thing for x plus 2. If I want to make this a factor of 1, then I got to multiply by x plus 2. So that has to be part of your least common denominator as well. And if you go to the next one, x minus 4 I already have, and x plus 2 I already have. And in fact, if you look at this right here, if I want this product to be 1, then I've got to multiply by this product, which is the LCD. Now the restrictions, because there are times when your proposed solution is not a solution to the original equation. So you have to look at the restrictions as well. And so the restrictions, remember, a rational expression is undefined when the denominator is 0. So you've got to determine in each of these cases where those denominators are zeros. What factors of x makes those denominators 0? So x minus 4 is 0, so you just set them each equal to 0, and you solve for x. So x minus 4 is equal to 0 when x is 4. So there's one of your restrictions. X cannot be 4 because that makes this denominator 0. You see, if you substitute 4 minus 4 is 0, 5 divided by 0 is undefined. So if you solve this equation and you get x equal 4 as the only proposed solution, then we have to say it's no solution because that was a restriction. So that's why you have to find the restrictions just in case your proposed solution is one of the restrictions. Then the next one, x plus 2, do the same thing. So x plus 2 is equal to 0 when x equals negative 2. So there's the other restriction. Then x minus 4, remember you got to go to each of those factors in all your denominators. X minus 4 I already did. X plus 2 I've already talked about. All right, so x plus 2 is going to be 0 when x is negative 2. X minus 4 is going to be 0 when x is 4. All right, now once you do all that, then the next step is to multiply, clear the fraction at the beginning, multiply both sides by the least common denominator. So what you had to do was this. You had to say, all right, my least common denominator is x minus 4. And notice that on the left side, there's only one rational expression. On the right side, there are two. So we're going to put this right side in parentheses in the next step. So I have this. I have x minus 4 times x plus 2. So the LCD times 5 divided by x minus 4 equal. Now the LCD times the right-hand side. Now we're going to put that in parentheses because there are two rational expressions here. So you can say x minus 4 times x plus 2 times the right-hand side. 1 divided by x plus 2 minus 2 divided by x. And when you do this one, go ahead and use the factored form. X minus 4 times x plus 2. And the reason you want to use this instead of x squared minus 2x minus 3 is because notice that when you distribute, this looks exactly like this. Okay, now we're going to distribute next. So I get x minus 4 times x plus 2. So the LCD times this rational expression times 5 divided by x minus 4 equal, and then this LCD times this rational expression. So x minus 4, x plus 2 times 1 divided by x plus 2 minus, and then the same thing here. So you're distributing the LCD on the right-hand side. X minus 4, x plus 2 times 2 divided by x minus 4 times x plus 2. All right, now we're going to reduce. So remember, the whole point of multiplying both sides by the least common denominator is to clear those fractions. So in other words, you want these factors to be factors of 1s. So x minus 4 divided x minus 4, anything dividing itself is 1, but you are left with factors of 1s in their case. And then over here, the x plus 2's divide out, you're left with factors of 1. And then over here, the x minus 4 times x plus 2 divides out with this one, so you're left with factors of 1s in both cases. And so now what we have is 1 times x plus 2 times 5, which is 5 times x plus 2, equal. And then x minus 4 times 1 is just x minus 4, minus, be careful here, you're subtracting, so be careful because this could be, it's a monomial here, but it could be a binomial or a trinomial or a polynomial. But that's just minus 2. So this is what we have now. So notice I don't have any more denominators. I mean, I do, and if you think of this as being over 1, but in terms of anything other than 1, you don't see it. All right, so now let's go ahead and distribute here. So I have, what happened is I went from a rational equation to a linear equation. Remember, a rational equation is not the same as a linear equation in this case because you have variables in the denominator, so that's a rational equation. This is linear. So the solution to this may or may not be a solution to the original. That's why you have to look at the restrictions. All right, so I get 5x plus 10 equal x, and then over here, a negative 4 to negative 2 is a negative 6. And notice, let's bring the variables to the left, the constants to the right. So I'm going to subtract x from both sides. So I get 4x plus 10 equal negative 6. Then subtract 10 from both sides. I get 4x equals a negative 16. And then divide both sides by 4. I get 4 divided by 4 is 1. 1 times x is x. I get x to be a negative 4. Now remember that's a proposed solution. So x equal negative 4 is a solution to this linear equation. But the question is it a solution to the rational equation? Well, is x equal negative 4 a restriction? No, it's not. So that's a solution. All right, so you had to check the restriction because you could have had it to where this is 4, and if you would not have checked, you would have said this is a solution and it would have been incorrect. All right, so that's number 1. So that's all you have to do, number 1. All right, so that's number 1. Now let's look at number 2. So number 2, we have this problem for number 2. So basically, you're adding or subtracting these complex numbers as indicated, and then it does say show all work to receive credit. All right, so, and then write your answer in the form a plus bi. So notice that in both cases, I'm multiplying this complex number by this complex number, and then this complex number by this one. But these two right here are both monomials, so I could distribute these monomials if I wanted to, and I will. So I get 2 times 3 is 6i, plus 2i times 5i. 2 times 5 is 10, I times I is I squared. And then distribute the 3, I get 3 times 1 is 3, and then 3 times a negative 2i is a negative 6i. All right, so that's what you have to show. That's part of the work. But I need to remember that I squared, remember, is a negative 1. So I'm going to replace this I squared with this negative 1. So I get 6i plus 10 times negative 1 plus 3 minus 6i. And then 10 times negative 1 is a negative 10. So I get 6i minus 10 plus 3 minus 6i. And then combining like terms, combining like terms, notice the 6i's cancel out, right? 6i minus 6i is 0. So I'm left with negative 3 plus 7, which is negative 7. Now, you could have left it like this, or you could have said in the form a plus bi. Some students did this. Some students will say negative 7 plus 0i. Okay? So either one's fine, though. All right, so that was number 2. Number 3, you want to divide the following complex numbers. Now, remember, you are dividing. You have this fraction, and in the denominator you have a complex number, so you have that I there. So you're going to have to you're going to have to rationalize this denominator. And you're going to do that by multiplying the numerator and denominator by the conjugate of 3 minus 4i. So the conjugate of 3 minus 4i is 3 plus 4i. And so what I had to see was this. I had to see this. I had to see 2i divided by 3 minus 4i, and then you had to say times 3 plus 4i divided by 3 plus 4i. So the numerator and denominator had to be multiplied by the conjugate of the denominator. And then you had to multiply. Now notice that here you have a monomial times a binomial, and here you have two binomials. So the next step you had to do was you had to say 2i times both of these terms here. So you had to say 2i times 3 is 6i. That's going to be your numerator so far. And then 2i times 4i is 8i squared. Then in the denominator, if you follow that out, you get 3 times 3 is 9. So notice this is what you have. You have 3 minus 4i times 3 plus 4i. So if you FOIL, you get 3 times 3 is 9. The outer, 3 times 4i is 12i. The inner, a negative 4i times 3 is a negative 12i. And then last, a negative 4i times positive 4i is a negative 16i squared. And so what you have now is this. You have now the out and the inner cancel out because 12i negative 12i is 0. But that's what you have. You have 9 minus 16. Remember, I squared we saw earlier was negative 1. So I'm going to write this as negative 16 times negative 1, which becomes 9 plus 16, which equals 25. So that's your denominator. So 3 minus 4i times 3 plus 4i is 25. But again, remember, I squared is negative 1, so this right here becomes 6i plus 8 times negative 1 divided by 25. And then 8 divided by negative 1 is a negative 8, but I'm going to go ahead and write it in the form a plus bi. So I'm going to go ahead and write this as negative 8 plus 6i divided by 25, which equals negative 6 divided by 25. I'm sorry, negative 8. Negative 8 divided by 25 plus 6i divided by 25. All right, so there's your work, and there's the answer. All right, so now it's number 3. Okay, so number four says perform the indicated operations and express your answer in standard form. So, standard form in this case would be a plus bi. And then for the work, show what you did to get your answer. Don't just write the answer. You got to show something. Show enough work to get full credit for the correct answer. So what you had to notice is that you could have gone off to the side and done each of these parts. So you know that the square root of negative 27, remember the square root of a negative 1 is defined to be I. You have to remember that part. And so this right here becomes the square root of a negative 1 times the square root of 27. And then you need to simplify your radical. Now you know that the largest perfect square that goes into 27 is 9. So this becomes the square root of a negative 1 times the square root of 9 times the square root of 3. And then the square root of negative 1 is defined to be I times, and then square root of 9 is 3, and then square root of 3. Which we prefer to write this, remember, whenever you have a radical as such, we always put the I. We tend to put the I between the 3 and the square root of 3, so that way if you put in the end and you make it look like the I is under the square root, that's incorrect. So that's why we tend to put it in front of the square root. So I'm going to write this as 3i square root of 3. All right, so this right here becomes 4 times 3i square root of 3. Okay, now let's talk about the square root of a negative 12. So this, I'm going to put that here. The square root of a negative 12 is defined to be, or can be rewritten as the square root of a negative 1 times the square root, and then 12 is 4 times 3. The 4 is the largest perfect square that goes into 12. So the square root of 4, square root of 3. So this is I, the square root of 4 is 2, and I cannot simplify the square root of 3, and I can rewrite this as 2i square root of 3. And so this is this part here. So that becomes plus 5 times 2I square root of 3. And so now we have this. We have 4 times 3 is 12. So this is 12I square root of 3 plus, and then 5 times 2 is 10. So I get 10I square root of 3. And those are like terms. So I can combine those. I have 12I square root of 3's and then 10 of them. So altogether I have 22I square root of 3's. So that's 22I square root of 3. Or if you wanted to, if you want to write in the form A plus BI, you could have said 0 plus 22I square root of 3. So either one of those is fine. All right. Now, number 5. So it's very important you follow directions. So the direction says solve by factoring. Don't use a quadratic formula. If you use a quadratic formula, you didn't follow the directions. All right, so you have to know how to be able to solve a quadratic equation by factoring as well, if it's possible to solve by factoring. We all know you can use a quadratic formula, but can you remember how to solve by factoring if you can solve by factoring? So that's why you have those kinds of problems. The idea of factoring, solving equation by factoring is important. Okay, and then show all work to receive credit. So what you have to do, again, we're doing this by factoring. So let's bring all the terms to one side because you got to put it in standard form. And you want 0 on the other side because you're going to be using the zero factor property. So I get 3x squared plus 14x minus 49 equals 0. And so if we factor the left-hand side, factor that quadratic trinomial, we can factor this as 3x minus 7 times let's see, x plus 7. So 3x minus 7 times x plus 7. If you follow this out, you'll get this back. Now remember, I'm using the zero factor property. So the zero factor property says that if you have 2 or more factors whose product is 0, one of those has to be 0. So the next step you had to say was this. You had to say 3x minus 7 equals 0, x plus 7 equals 0. Show all work to receive full credit. Don't be lazy on these problems. You know what's required to get your points. All right, and then you solve each linear equation. So notice I went from a quadratic equation to 2 linear equations, and so therefore we get 3x equals 7, and x is 7/3. Over here I get x to be -7. So those are your 2 solutions, 7/3 and -7. All right, so that's number 5. All right, so problem 6 says solve the following quadratic equation by using the square root property. Again, follow directions. Use the square root property. Show all work and then simplify radicals if possible. So what you have to do here, notice that when you're using the square root property, you can use the square root property to have, remember, something squared equal a number, and then you could take the square root of both sides. And so that's what you see here. Some expression squared equal a number. Now that number is negative, and we're going to remember how to deal with that, but that's when you can use the square root property. So the next thing you're going to do is say this. So basically, you're going to do this. So all I did was rewrote the problem. So you can take the square root of both sides, just like that. Now remember, you take the square root of both sides, you got to do that plus or minus. Okay? So then the square and the square root undo each other, so you're left with the expression on the left side, 4x minus 3. And on the right side, plus or minus, and remember the square root of a -81 is the square root of -1 times the square root of 81, and then 81 is a perfect square, so the square root of 81 is 9. The square root of -1 is I, so that's 9I. So that becomes plus or minus 9I. All right, now notice that your solutions, you're solving, so your solutions are going to be complex numbers. So what we did to make it more compact was we did this. So we just added 3 to both sides. So 4x equals 3 plus or minus 9I, and then we divided by 4. So divide both sides by 4. 4 divided by 4 is 1. So you get x to be 3 plus or minus 9I divided by 4. Now, you could have also written it as 2 separate, I'm going to write this as set. So 2 separate solutions. So you could have said 3 plus 9I divided by 4, comma, 3 minus 9I divided by 4. Okay? And then some students even went further and they said this. They said 3/4 plus 9i divided by 4, comma, 3/4 minus 9i divided by 4. So these are all solutions. These are all ways of writing the solutions that students did. All right, so that was number 6. Okay, number 7. Now again, number 7, follow directions. It says solve this quadratic equation by completing the square. Do not use quadratic formula because that's not what that says. That says complete the square. All right, using any other method, such as the quadratic formula, will give you a score of 0, and some of you still did that. So I'm not sure why even though it says the statement, you continue to use the quadratic formula. All right, so let's let's remember how to solve this quadratic equation by completing the square. So first of all, remember that the coefficient of x squared has to be 1, and it is here. And so we're going to bring the constant to the other side. And so we're going to have x squared minus 12x. Leave some space here. I'm leaving some space. And then that becomes negative 23. That equals negative 23. Now now the next step is you're going to add 2 numbers to each side. And those are the same numbers. What you do to one side, you do to the other. Now here's how you get that number right here. You take the coefficient of x, which is negative 12. Always divide by 2. And once you divide by 2, you got to square that number. So negative 12 divided by 2 is a negative 6, and a negative 6 squared. So a negative 6 times itself is a positive 36. And that's what you add to both sides. And so now remember, once you do that, this should now be a perfect square trinomial, which means now you can write it, which means now it's going to look like this. It's going to look like this kind of problem. And so over here, negative 23 plus 36 is 13. And over here, when you factor this, that's going to be x minus 6 squared. So x minus 6 times x minus 6 is this trinomial. And now we're going to use what we did here. So we're going to use the square root property. So we go ahead and rewrite this over. And then I'm going to take the square root of both sides. Don't forget the plus or minus. All right, and so the square root and the square undo each other, so you get x minus 6 equals plus or minus square root of 13. Now, since these are irrational solutions, we're going to write in compact form like we did the complex solutions. And so I'm going to add 6 to both sides, and so I get x equals 6 plus or minus the square root of 13. And there's your answer. And again, some students wrote it like this. I'm going to write this as a set. Some students wrote it as 6 plus the square root of 13, comma, 6 minus the square root of 13. Okay, so the two distinct solutions means the same thing as this. All right, so that was number 7. All right, so number 8 is now they're saying use a quadratic formula. All right, so solve this quadratic equation by using quadratic formula. Simplify any radicals if possible. Show all required work to receive all points for correct answer. And I even gave you a quadratic formula. Now, notice when using a quadratic formula, you have to have 0 on the other side. And then let's put it in, it's already in descending order. So before we use quadratic formula, let's denote what a, b, and c are. So a is a coefficient of x squared, so a is 2. B is a coefficient of x, so b is a negative 3. And c is your constant, which is a negative 6. So we have a, b, and c, so we're going to substitute into the formula. So I get x equals, so remember this says negative b, so that means the opposite of b. So b is a negative 3, the opposite of negative 3 is a positive 3. Plus or minus the square root of b, which is negative 3 squared, minus 4 times a, which is 2, times c, which is negative 6, all divided by 2 times a, and a is 2. So you had to say that, okay? Show all required work. Then let's go ahead and simplify the radicand. So I get 3 plus or minus the square root of negative 3 times itself is 9. A negative 4 times 2 times a negative 6 is a positive 48 divided by 4. And so that becomes 3 plus or minus the square root of 57 divided by 4. And then at this point, you'll notice that the square root of 57 cannot be simplified. The only perfect square that goes into 57 is 1. So that's your answer. Now, if you wanted to, you could have written it as as two separate solutions. So you could have said 3 plus the square root of 57 divided by 4, comma, 3 minus the square root of 57 divided by 4. All right, so that was number 8. Okay, so number 9 says solve the following square root equation and then show all work to receive credit for answers. Show that you have checked for extraneous solutions. Now, normally we don't say that because it's understood that you would do that, but I'm giving you a big hint there so you don't lose any points, and that was to check for extraneous solutions. So sometimes when students are given an equation like this, they forget about the idea of extraneous solutions. I am giving you the hint. You need to check for extraneous solutions. All right, so and then circle the solutions. Okay, so when solving a square root equation, notice that on both sides you have variables, okay? And when solving a square root equation, you want to make sure that the square root expression is by itself, and it is. Because once it's by itself, I'm going to go ahead and rewrite this over. Once it's by itself, then to get rid of the square root symbol, you're going to raise both sides to the second power. And to the second power because that exponent has to equal your index. So if this is square root, the index is 2, the exponent has to be 2. And so therefore these will undo each other. And so you get 3x minus 2 equals, and then you have this binomial square. So you're going to FOIL this out. So x minus 4 times x minus 4 is what you're thinking about. And so when you FOIL this out, you get x times x is x squared. The outer is a negative 4x. The inner is a negative 4x. And the last, a negative 4 times negative 4 is a positive 16. And you get x squared minus 8x plus 16, and that goes here. So this is this. So x squared minus 8x plus 16. So notice how it went from a radical equation, a square root equation, to a quadratic equation. All right, now remember, those are separate equations. So the proposed solutions to this quadratic equation may or may not be a solution to the other one, to the original. Okay, so that's why you have to check for extraneous solutions. All right, now remember, this is quadratic, so we're going to bring all the terms to one side. So I'm going to subtract 3x on both sides. And so when I do that, 3x minus 3x is 0, so I get negative 2 equals x squared. A negative 8x and a negative 3x is a negative 11x plus 16. Then I'm going to add 2 to both sides. And so I'm going to get 0, negative 2 plus 2 is 0, equals x squared minus 11x plus 18. And I'm going to go ahead and transpose both sides. So I'm going to put the 0 on the right-hand side. So I get x squared minus 11x plus 18 equals 0. Now, you could use quadratic formula at this point, or you can factor, or you could try to factor. And I did tell you previously that the one in your test will be factorable. So let's go ahead and factor this. So I get x minus 9, x minus 2. So that's how you're going to factor this. And then we're going to use the zero factor property. So we're going to say each of those equal to 0. So x minus 9 equals 0, x minus 2 equals 0. And notice I went from a square root equation to a quadratic equation to two linear equations. So x minus 9 is equal to 0 when x is 9, and x minus 2 is equal to 0 when x is 2. Now those are your proposed solutions to the original. So you have to check. And so notice I said, show that you have checked. Show that you have checked. So let's check. You always go back to the original. So let's check x equal 9. So go back to the original. Here was the original. The square root of 3x minus 2 equals x minus 4. So in place of x, I'm going to substitute 9. So I get the square root of 3 times 9 minus 2. And I want to see if that's going to equal x, which is 9, minus 4. Well, 3 times 9 is 27. So I get the square root of 27 minus 2. And 27 minus 2 is 25. So I get the square root of 25, which is 5. And 9 minus 4 is 5, and those are equal. So x equal 9 will be, this proposed solution is a solution to the original problem. Now let's check x equal 2. So let's check x equal 2. So that you have to show this. So the original equation was the square root of 3x minus 2 equals x minus 4. And so wherever we see the variable x, I'm going to substitute 2. So I get the square root of 3 times 2 minus 2. And I want to see that's going to equal 2 minus 4. Well, 3 times 2 is 6. So the square root of 6 minus 2. 6 minus 2 is 4. And so the square root of 4 is 2. But 2 minus 4 is a negative 2. Those are not equal. So x equal negative 2, that's an extraneous solution. So meaning that that's a false solution to the original. So it's a solution to this linear equation. It's a solution to this quadratic equation, right? But it's not a solution to the original, and that's what you're trying to solve. So that's why you have to check for extraneous solutions. So the only solution is x equal 9. But you have to show this and indicate that this was not a solution, that was extraneous. All right, so that's number 9. All right, that's number 9. All right, let's look at number 10. All right, so number 10 was an absolute value equation. And when solving an absolute value equation, you got to get the absolute value bars, the absolute value expression by itself. So let's go ahead and add 4 to both sides. So when I add 4 to both sides, I get the absolute value of 3x minus 7 is equal to 10. Now at that point, you want to rewrite this without the absolute value bars. All right, so that's where you would split it apart. So you would say 3x minus 7 is equal to positive 10, and then 3x minus 7 is equal to the opposite of 10, so negative 10. So those are your two equations. So notice I went from an absolute value equation to two linear equations. And then it's just a matter of you solving these linear equations. So I'm going to add 7 to both sides. I get 3x equals 17. Divide both sides by 3. One of your solutions is 17 thirds. Over here, add 7 to both sides. I get 3x equals a negative 3. Divide both sides by 3. I get x to be negative 1. So there's the other solution. Okay? And then finally, number 11. So number 11 was a compound inequality. And so you had, notice you do have a fraction. So your LCD here is 2. So you can multiply all parts by 2. So you're going to say this. Let me go ahead and rewrite this over. So you have negative 8 is less than, I'm going to leave some space here. 2x minus 3 divided by 2 is less than, I'm going to leave some space here, 4. So remember, you want to clear that fraction, so you can multiply all parts by the LCD, which is 2. So you can say times 2, times 2, times 2. And then so 2 times negative 8, so negative 16 is less than, these 2's divide out. So you get 1 times 2x minus 3 is 2x minus 3 is less than or equal to 2 times 4 is 8. And then all you have to do now is just get the variable in the middle by itself. So you're going to add 3 to all parts, just like this. And so you get negative 13 is less than 2x is less than or equal to 11. And then finally, you're going to divide all parts by 2, the coefficient of x, to get x by itself in the middle. And so you get negative 13 halves is less than x is less than or equal to 11 halves. So any real number between these two will be a solution to the original compound inequality. All right, and now for the graph, all you had to do, you didn't have to put numbers on these things. And when I mean by numbers, I mean like 0, 1, 2, 3, negative 1, negative 2, negative 3. All you had to do was since you're doing it by hand, was just put a little tick mark with negative 13 halves over here, and then a tick mark with 11 halves. Now remember, less than, so that's parentheses, okay? Now put the parentheses on that tick mark. We've mentioned that in those lessons. Then 11 halves, that's an equal sign, so that means that 11 halves 11 halves will be a solution to the original equation, but you're going to put a bracket there on that tick mark just like that. And then you shade in. So the shading in means that any real number that's in here, and there's an infinite number of those, an infinite number of solutions here. So any number in here will be a solution to the original. And so interval notation, you have to say, and you just read it from left to right, parentheses, negative 13 halves, comma, all the way to 11 halves with a bracket. And that was it. So that is, let me get that first page. So that is the key to test one.